Hello everybody, welcome to Guidancee Education channel. Let us see the topic that is discussed in this video. We are continuing class 11 chemistry, classification of elements and periodicity of properties. Under that, this is part 5, periodicity of properties. We will be doing some questions based on atomic and ionic radii. This video will help to reinforce or understand better the points that you learned under atomic and ionic radii. So watch the video completely without skipping so that you get all points cleared. And if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not subscribed my channel, do subscribe it now and support me. Press the bell button and all button for notification of more videos like this. Thank you very much. Come, let us start the class. We will do a few questions based on atomic and ionic radius. This will help to understand the concepts regarding these two topics more clearly. Let us see the first problem. Which of the following pairs have a larger size? Explain. Potassium atom or potassium ion, bromine atom or bromide ion, oxygen 2- ion or fluoride ion, lithium ion or sodium ion, phosphorus atom or arsenic atom, sodium ion or magnesium 2+ ion. There are 6 pairs given. You have to identify the larger one in each pair and you have to justify your answer. You have to give reason why you have selected a particular one as the larger one. A. Potassium or potassium cation. In these two cases, the nuclear charge Z is equal to same. Potassium ion has 1 electron less than the neutral atom. So the nuclear electron attraction will be more in the case of potassium ion, which makes that ion smaller than the parent atom. So the answer is potassium atom is bigger than potassium ion. The reason is the electron-electron repulsion in potassium atom is greater than the nuclear electron attraction. Next one, B. Bromine atom or bromide ion, which is the bigger one. Bromide ion, which is an anion, will be greater than the parent atom because the bromide ion has 1 electron more than the bromine atom. At the same time, the nuclear charge remains the same. Therefore, bromide ion is bigger than bromine atom. Here also, the electron-electron repulsion in bromide ion is greater than the nuclear electron attraction. Next section, C. O2 negative or fluoride ion, which is the bigger one. Atomic number of oxygen is 8 and that of fluorine is 9. Oxygen 2- has 2 electrons more and fluorine negative has 1 electron more. So total number of electrons in O2- is equal to 10 and F negative also is equal to 10. So we find that they are isoelectronic anions. We have already seen that in isoelectronic species, it is the nuclear charge that decides the size of the ion. Greater the Ze ratio, less will be its ionic size. The Ze ratio for oxygen 2- will be 8 divided by 10, which will be 0.8. And for fluoride ion, it will be 9 divided by 10. That will be 0.9. So obviously O2- ion will be bigger than the fluoride ion. Reason is nuclear charge of oxygen 2- is less than that of fluoride ion. Next one, D. Lithium ion or sodium ion, which is bigger. Obviously, lithium belongs to second period, so it has only 2 shells. But sodium belongs to the third period, so it has 3 shells. So naturally, sodium ion is bigger than lithium ion. So the reason is sodium has 3 shells, whereas Lithium has only 2 shells. Atomic radii and ionic radii increase with increasing number of shells, that is down the group. Next one, E. Phosphorus or arsenic, which is bigger. Both are neutral atoms. Phosphorus belongs to the 3rd period and arsenic belongs to the 4th period. They belong to the same group. So, arsenic is bigger than phosphorus. So, the reason is arsenic has 4 shells but phosphorus has only 3 shells. Next one and the last one in this series, F. Sodium ion or magnesium 2 plus ion, which is bigger. Atomic number of sodium is 11 and that of magnesium is 12. Sodium plus and magnesium 2 plus are isoelectronic. They belong to the same period because sodium has lost 1 electron and magnesium has lost 2 electrons. Therefore, the number of electrons become 10. The ZE ratio for sodium will be 11 by 10 equal to 1.1 and for magnesium it will be 1.2, that is 12 by 10. Therefore, sodium plus ion will be bigger than magnesium 2 plus ion. Greater the ZE ratio, smaller will be the size of the ion. So for isoelectronic species, the ZE value can be taken as a criteria. Across the period, when the nuclear charge increases, ionic size decreases. But down the group, when nuclear charge increases, ionic size increases. Please remember these details. Let us pass on to the second question. Arrange the following in the order of increasing radii. A. Iodine atom, iodine cation and iodine anion. B. Carbon, nitrogen, silicon, phosphorus. C. Oxygen 2 minus, nitrogen 3 minus, sulfur 2 minus and fluorine minus. Section A. Iron is a non-metal. Its tendency is to gain 1 electron and become iodine negative ion. Here iodine cation also is given. Okay, let us answer it. Iodine cation will be smaller than the iodine atom because the cation has 1 electron less than its parent atom. So the nuclear electron attraction will overweigh the electron-electron repulsion. Whereas in iodine anion, it has 1 electron more. Therefore, the electron-electron repulsion will be more than, that is, it will overweigh the nuclear electron attraction. So the anion of iodine will be the largest and iodine cation will be the smallest. We have to arrange them in the increasing order. So we have to start from the least size. So iodine positive less than iodine less than iodine negative ion. You need not note down the reason, but unless you know the reason, you cannot arrange this. Next one, B. Carbon, nitrogen, silicon, phosphorus. All are neutral atoms. Among them, carbon and nitrogen belong to second period. Atomic number of carbon is 6 and that of nitrogen is 7. Carbon belongs to 14th group and nitrogen belongs to 15th group. Across the period, the atomic size decreases. So, nitrogen is smaller than carbon. Silicon and phosphorus belongs to the third period. Silicon belongs to the 14th group and phosphorus to the 15th group. Atomic number of silicon is 14 and that of phosphorus is 15. So, silicon will be bigger than phosphorus. Silicon will also be bigger than nitrogen and carbon. So, in this group, silicon is the biggest and nitrogen will be the smallest. So, the order will be nitrogen less than carbon, less than phosphorus, less than silicon. Next one, C. Oxygen, nitrogen and fluorine belong to second period. Sulfur belongs to the third period. For O2 minus, there are 10 electrons. In nitrogen 3 minus also there are 10 electrons. In sulfur 2 minus there are 18 electrons. In fluorine negative ion also there are 10 electrons. So we can understand O2 minus, N3 and F negative are all isoelectronic anion. When we arrange oxygen, nitrogen, and fluorine in the increasing order of their atomic number, it will be nitrogen, oxygen, and fluorine. For isoelectronic anions, the ionic size decreases with increase in nuclear charge. So the order will be fluorine negative less than oxygen 2 minus less than nitrogen 3 minus less than sulfur 2 minus. Sulfur 2 minus is the biggest. Hope this video helped you to understand the concept in these two topics. If you need more questions, you may leave it in the comment box below. We will meet in the next video with another important topic, that is another periodic property. Do not forget to subscribe. Thank you. Bye for the present. Take care.